2.4 Exponential Growth. Southwestern College, Professor Maria Olivas. Exponential growth. Objectives. Find functions that satisfy dp dt equals k times p. Determine growth rate. Solve applications involving exponential growth. 1. Exponential growth. Recall that functions of the form y equals c times e raised to the kx power, where k is greater than 0, represent exponential growth. The derivative function is dy dx equals c times e raised to the kx power times k, and this can be written as dy dx equals k times c times e raised to the kx power. But the c times the e to the kx power is just equal to y, so we can just replace that entire thing with y, so that's actually equal to just k times y. I'm going to lasso everything I wrote here, I'm going to shrink it, and I'm going to move it slightly to the left. Notice that the derivative is just a constant multiple of k times the original. That is, dy dx is equal to k times y, if and only if y equals c times e raised to the kx power. Example 1. Find the function that satisfies the relationship dA dx equals 2 times a. Here k is equal to 2, because this is the constant multiple being multiplied to the a. So if k is equal to 2, then this means a is equal to c times e raised to the 2x power. And this would mean that a of x equals c times e raised to the 2x power. I'm going to go ahead and box that equation in. That's going to represent our function. Example 2. Find the function that satisfies the relationship dp dt equals 1.8 times p. Here, k is equal to 1.8. I've highlighted the 1.8 in our derivative function and where it says k equals 1.8. I highlighted the 1.8 in yellow. I've also gone ahead and I've highlighted everywhere we had our k constant multiple in example 1 in blue, so you can see and you could compare these two. And now I've gone ahead and I've highlighted in green everything in example 1 that represented our function a. In this case, our function is named p. So I'm going to make sure that when I write my function, I'm going to write p of t, because the variable in the denominator, if you notice, it's a t when we were looking at the dp over dt part. I've gone ahead and I've highlighted in blue the 1.8 for our constant multiple. And I've gone ahead and written p of t equals c times e raised to the 1.8 times t. And I've highlighted all my t's in yellow. Gone ahead and boxed in this function. Now we're going to evaluate p of 0. P of 0 is going to be equal to c times e raised to the 1.8 times 0 power. This is equal to c times e raised to the 0 power, which is just equal to c times 1, which equals c. I've boxed in my c. This leads us to our uninhibited population growth model. So dp dt is equal to k times p, which can then be written as p of t equals c times e raised to the kt power, which then can be written as p of t equals, I've highlighted up above our c and our p of 0, and I've underlined them in red. and I've written a little star here underneath the C, and I've written that C is equal to P of 0. So I'm going to replace our C with P of 0. So P of t is equal to P of 0 times e raised to the kt power. I'm going to go ahead and box that function in. I'm going to write down here k equals our growth rate. P of 0 is going to be equal to our initial value. And now I'm going to go ahead and draw a sketch of this function. Over here to the right, I'm going to label my axes. My x-axis is going to be labeled with a t. My y-axis is going to be labeled with a p. And I'm going to draw an exponential function that is increasing. This exponential function has a y-intercept at 0, p sub 0. And I've labeled my function with P of t. I have highlighted in yellow the words that say uninhibited population growth model, and I have drawn a red cloud around those words. And this is what we have just represented. Example 3. Suppose the balance of money invested in an account grows according to the model dp dt equals 0.05p. I'm going to draw a cloud around that function, around that derivative function. I've drawn an arrow pointing to the right from our cloud and from our derivative function, and now I'm rewriting the original function, P of t. P of t is equal to c times e raised to the 0.05 times t power. So here our growth rate is going to be equal to 5%, which can be written as 0.05 or 5/100ths. A. Given $5,000 is invested initially, write the function P of t. So I've underlined where it says $5,000 is invested initially, and I've also underlined where it says write the function P of t, and I've circled P of t. So we're going to go ahead and write here P of t equals, and we're going to replace our C with 5,000 because that's what C represents. It represents our initial value, and they did say here that 5,000 is invested initially. I've highlighted the word initially in yellow, and I've highlighted my C from up above in yellow. I've drawn a red cloud around my C, pointing an arrow downwards to where I'm about to replace my C with 5,000. I've also drawn a red cloud around my $5,000. So P of t is equal to 5,000 times e raised to the 0.05 times t power. I'm going to box that function in. To the right-hand side of where I wrote this function, I'm writing down I am writing down A equals P times E raised to the RT power inside parentheses, and I'm writing down underneath it, this is our formula for interest compounded continuously. And if you notice, these two equations are set up exactly the same. B, what is the balance after 4 years? P of 4 is equal to 5,000 times E raised to the 0.05 times 4 power, which is approximately equal to $6,107.01. C. When will the account have doubled in value? To double $5,000 means it would turn into $10,000. I've highlighted the entire instructions for C, so I've highlighted when will the account have doubled in value, and I highlighted that in yellow. I drew a red cloud around the word when, because we're looking for time, and I drew an arrow pointing towards the right. I need to find time. In other words, I need to find t. So I'm going to write down my function. P of t equals 5,000 times e raised to the 0.05 times t power. I'm going to replace P of t with 10,000, because that's what I want my investment to turn into. I want it to double. So I'm going to write down 10,000 equals 5,000 times e raised to the 0.05 times t power. And now I'm going to solve for t. I'm going to divide both sides of my equation by 5,000. The 5,000s will divide out on the right-hand side, and on the left-hand side, 10,000 divided by 5,000 is equal to 2. So we have 2 equals e raised to the 0.05 times t power. I'm going to go ahead and I'm going to lasso the part that says double 5,000, and then with an arrow pointing to the right, it turns into $10,000. And I'm going to shrink it, and I'm going to move it slightly to the left. All right, so the 2 equals e raised to the 0.05 t power. I'm going to draw an arrow that points this equation towards the upper right-hand side of the screen here, and I'm going to rewrite that equation. 2 equals e raised to the 0.05 t power. I'm going to take the natural log of both sides. And then when I take the natural log of both sides, I can rewrite the right-hand side using the power property for logarithms. So first I'm going to have natural log of 2 equals the natural log of e raised to the 0.05 t power. Then I'm going to write the natural log of 2 equals 0.05 times t times the natural log of e. I can replace the natural log of e with 1. So the natural log of 2 equals 0.05 times t times 1. And then I can divide both sides by 0.05. The 0.05s will divide out on the right-hand side of the equation, and we will have t is equal to the natural log of 2 divided by 0.05 years. So t is approximately equal to 13.86. So that means it's about 14 years. I'm going to box in the part that says t equals natural log of 2 divided by 0.05 years. That's going to be my exact answer. I have lassoed in my answer, I have shrunk it slightly, and I have raised it upward. Underneath it, I am writing t is approximately equal to 13.86. Which means that this is approximately equal to about 14 years. D. Redo part C if the initial value is $8,000. Again, if the initial value is $12,000, what do you observe? I am going to circle the part that says C if the initial value is $8,000. So we're going to do that part first. So we're going to call that our part 1. So I'm going to label this as number 1. And then I'm going to write down P of T equals 8,000 times E raised to the 0.05 T power. I'm going to replace the P of T with 16,000 because if you double 8,000, you get 16,000. 16,000 equals 8,000 times e raised to the 0.05 t power. I'm going to divide both sides by 8,000, so I'll get 2 equals e raised to the 0.05 t power. I'm going to take the natural log of both sides of the equation, so I'll get natural log of 2 equals the natural log of e raised to the 0.05 t power. And now I'll have natural log of 2 equals 0.05 times t. And if I divide both sides by 0.05, I will end up with t equals natural log of 2 divided by 0.05. And I'm going to label that with the units of years. I'm going to box that in. So that's my answer for part 1. I'm going to draw a vertical line segment to separate the work I did for the part 1 from the part 2. So for part 2, I'm going to write down P of T equals 12,000 E raised to the 0.05 T power. I'm going to replace P of T with 24,000 because if I double 12,000, I get 24,000. So 24,000 equals 12,000 times E raised to the 0.05 T power. If I divide both sides by 12,000, I get 2 equals E raised to the 0.05 T power. And if I take the natural log of both sides, I get the natural log of 2 equals the natural log of E raised to the 0.05 T power. And then I will get natural log of 2 equals 0.05 t, and if I divide both sides by 0.05, I get t is equal to the natural log of 2 divided by 0.05 years. I'm going to label that with years, and I'll box that in. So if you notice here, both of our answers were exactly the same. We got the exact same answer as we did from our previous part C problem. So from this, we can deduce that there is a pattern here. For example 4, it says, suppose a company's customer base doubles in 6 months. What was the exponential growth rate during that period? Well, based off of what we've done from our previous problems, we can go ahead and write down that t is going to be equal to the natural log of 2 divided by r, which represents our rate. I have underlined the part that says doubles in 6 months, and I have underlined the part that says exponential growth rate during that period, because that's what we're looking for. And then I was able to come up with this formula, t equals the natural log of 2 divided by r, based off of what we've done in the previous problem. So I went ahead and I drew stars next to the 2 answers that I just found in part D to show you where I came up with this formula from. Now, because it's saying that this customer base doubles in 6 months and we can't use months, we are going to have to convert this to years. I'm going to write 6 months over 1 times 1 year over 12 months. I am doing this in order to convert our months into years. So 6/12 of a year is equal to half a year, which can also be written as 0.5 or 5/10 of a year. So I'm going to replace t with 0.5. So I have drawn an arrow from the place where I figured out my 0.5 of a year. I've drawn an arrow pointing to the upper right hand side of the screen here, and I replace my t with 0.5, so I have 0.5 equals natural log of 2 divided by r. In the problem here, they're asking for us to find the growth rate. So I pointed an arrow pointing to the r, and I said we are solving for r. R represents our rate. And I went up ahead to the problem where it says what was the exponential growth rate. I've underlined it and I've circled the words growth rate. So we're going to go ahead and solve for r. I'm going to multiply both sides of my equation by r. So 0.5 times r is equal to the natural log of 2 divided by r times r over 1. I'm going to cross cancel the r's on the right hand side of the equation. On the left hand side of the equation, in order to solve for r, I'm going to have to divide both sides by 0.5. So I'm going to divide both sides of the equation by 0.5. The 0.5s will divide out on the left-hand side, and I will be left with r equals natural log of 2 divided by 0.5. This is approximately equal to 1.386. This represents a rate, so I'm going to convert this to a percentage. So r is approximately equal to 138.6%. I'm going to go ahead and lasso in all the work I did on the right hand side. I'm going to shrink it and move it slightly upwards. I'm going to box in my answer that says r is approximately equal to 138.6%. Example 5. Suppose $1,000 is invested in a fund with interest compounded continuously at 6.2% per year. I have drawn a cloud around the $1,000, and I have drawn a cloud around the words compounded continuously, and then I have drawn a box around 6.2%. So that is that dp dt is equal to 0.062p. If we convert our 6.2% to decimal, it's going to turn into 0.062. A, write the function p of t. P of t is going to be equal to 1,000 times e raised to the 0.062 t power. So I'm going to go ahead and box in that function. I have replaced my c, or my constant multiple, with that 1,000, which represents the initial value of our investment. And I replace my growth rate with 0.062. B, when will the money in the account be doubled? In order to double $1,000, it needs to turn into $2,000. So I'm going to replace our P of t with 2,000. So 2,000 is equal to 1,000 times e raised to the 0.062 t power. I will divide both sides by 1,000. On the right hand side, the 1,000s divide out. On the left-hand side, 2,000 divided by 1,000 is equal to 2. So 2 is equal to e raised to the 0.062 t power. I'm going to draw an arrow from this equation pointing upwards to the upper right hand side here, and I'm going to rewrite this equation by taking the natural log of both sides. I'm going to write natural log of 2 equals the natural log of e raised to the 0.062t power. The natural log of 2 is equal to 0.062t times natural log of e. The natural log of e can just be replaced with a 1. So natural log of 2 is equal to 0.062t times 1. So the natural log of 2 is equal to 0.062t. I'm going to lasso all the work I've done so far for part B. I'm going to shrink it. And I'm going to move it slightly towards the left so I have more space. Now I'm going to draw another arrow from my last equation that I wrote, pointing to the upper right-hand side of the screen here. And I'm going to write natural log of 2 equals 0.062t. In order to solve for t, I'm going to divide both sides by 0.062. On the right hand side, the 0.062's cancel out, or they divide out. So t is equal to the natural log of 2 divided by 62 thousandths. And I'm going to label the units here in years, and I'm going to box that in. So t is approximately equal to 11.180 years, or about 11 years. C. How long will it take for the money in the account to triple? In order to triple $1,000, we need it to be converted into $3,000. So I'm going to write down the word triple, and then next to that I'm going to write $1,000 and an arrow pointing to the right, and I'm going to write down $3,000. So if we want to triple $1,000, we want to convert it into $3,000. So I'm going to replace P of t with 3,000. So 3,000 equals 1,000 times e raised to the 0.062t power. I'm going to divide both sides by 1,000. So 3 is equal to e raised to the 0.062t power. I'm going to take the natural log of both sides. I'm going to point an arrow pointing to the upper right-hand side of the screen here, and I'm going to rewrite my equation, but I'm going to apply that power property for logarithms. So the natural log of 3 is equal to 0.062t times the natural log of e. So the natural log of 3 is equal to 0.062t. I'm going to divide both sides by 0.062. On the right-hand side, the 0.062's will divide out, and we'll be left with t is equal to the natural log of 3 divided by 0.062. I've highlighted the 3, and I've highlighted the 2 in the answer to the previous problem. Notice how it went from natural log of 2 to natural log of 3. I have circled those, and I've drawn an arrow pointing from the 2 to the 3. When we found the answer to part B, we were looking for when the money doubled. So that's why it has a natural log of 2 to represent that it doubled. And then when we asked to see, we wanted to see how long the money would triple, we have natural log of 3. So that's why it's a 3, because that's going to represent in how much time the amount of money would have tripled. So I've gone ahead and I've labeled my answer here with years. So t is equal to natural log of 3 divided by 0.062. And the units are years. I've boxed that in. And this is approximately equal to 17.720 years, which is about 18 years. I've gone ahead and I've highlighted also my growth rate in green, so you can see everywhere I had my growth rate here, how that did not change. That stayed the same. And there, we are done with that problem. Example 6. Suppose we know that a company's stock prices have been growing exponentially at a rate of 24% per year, with t equal to the number of years since the company started in January of 1992. I've gone ahead and I've highlighted in yellow where it says growing exponentially, and I've highlighted in yellow rate of 24% per year, and I've highlighted in green t equals number of years since the company started in January of 1992. A. If the company's initial stock price was $20 per share, write a function that relates stock price P to years T since the company started. I've circled P in the problem and I've underlined where it says years T. So I know when I find my function here, I'm going to call my function P of T. My rate is going to be equal to 24%, which I'm going to rewrite as a decimal. So this is equal to 24 hundredths or 0.24. I've highlighted in blue where it says initial stock price was $20 per share. Since that's the initial price, that's going to represent my initial value. I have drawn a cloud around where it says $20 per share. So P of T is going to be equal to, we'll replace our C or our initial value with 20, and then 20 will be multiplied with E raised to the 0.24 T power, and we're going to box that in. That is going to represent our function that relates stock price to years. B, use your model to determine the stock price in 2022. I've circled the year 2022. So what we need to ask ourselves, how many years since 1992? How many years have passed since 1992? I'm going to subtract 1992 from 2022. If I subtract these 2 years, I'm going to end up here with 30 years. So I'm going to go ahead and find P of 30. P of 30 is going to be equal to 20 times E raised to the 0.24 times 30 power. And this is going to be approximately equal to $26,788.62. We're going to go ahead and box that in. Example 7. The cost of a gym membership in 1990 was $20 per month. In 2000, the cost of that same membership was $25 per month. Suppose the cost of the membership is growing exponentially. I've highlighted the year 1990 in yellow. I've highlighted $20 per month in yellow. I've highlighted in green the year 2000, and I've highlighted in green $25 per month. And I've highlighted in blue, suppose the cost of the membership is growing exponentially, and I drew a red cloud around the word exponentially. A, determine the growth rate for the gym membership. I've underlined the words growth rate, since that's what I'm looking for. So I'm going to go ahead and write down my function. M of T equals C times E raised to the KT power. I'm going to go ahead and highlight in yellow our K because K represents our growth rate. I'm also going to highlight in yellow the words growth rates from the Part A instructions. So this is what I'm looking for. Let's go ahead and replace C with 20 because C is equal to 20 because 20 represents the initial cost of the membership in 1990. I'm going to draw a cloud around I'm going to go ahead and write down the function M of T equals 20 times E raised to the KT power. I've drawn a red cloud around this function. So now I'm writing next to this function towards the right, I'm writing when T is equal to 10, comma, and M is equal to 25. This is what I need to find what the growth rate was. So I'm going to go ahead and subtract 1990 from 2000, and I'm going to get 10. So that's going to represent the 10 that I got for T equal to 10, the 10 years. I'm going to replace M of T with 25. So I'll have 25 equals 20 times E raised to the K times 10 power. So 25 is equal to 20 times E raised to the 10K power. I'm going to divide both sides by 20. The 20s will divide out on the right-hand side. And then on the left-hand side, I'll have 25 divided by 20. I've drawn an arrow pointing towards the right. 25 divided by 20 is equal to 1.25, which is equal to E raised to the 10K power. I'm going to take the natural log of both sides. So the natural log of 1.25 is equal to the natural log of e raised to the 10k power. From this equation, I've drawn an arrow pointing to the upper right-hand side of the screen here, and I'm going to write natural log of 1.25 is equal to, and I'm going to bring down that 10k power in front of the natural log of e. The natural log of e is just going to be equal to 1. I've gone ahead and I've drawn a curly bracket above the natural log of e, and I've written the number 1 above it. So 1 times 10k is just going to give me 10k. So I'm going to write 10k equals the natural log of 1.25. I'm going to divide both sides by 10. So k is equal to the natural log of 1.25 divided by 10. This is approximately equal to 0.0223. Because this represents a rate, I'm going to convert this to a percent. So our rate is approximately equal to 2.23%. And I'm going to box that in. I'm going to lasso all the work that I just did for part A. I'm going to lasso that, I'm going to shrink it, and I'm just going to move it slightly upwards and to the right here, just a little bit. So I have more space for my part B problem. B, write the function m of t that represents the cost of the membership t years after 1990. So m of t is going to be equal to 20 times e raised to the 0.0223 times t power. And I'm going to go ahead and box in my function. C, using your function, predict the cost of the membership in the year 2020. So here we need to ask ourselves, how many years after 1990? How many years have passed since 1990? So I'm going to subtract 1990 from 2020. Our difference is going to be 30 years. So t is going to be equal to 30 years. So I'm going to go ahead and write m of 30 is equal to 20 times e raised to the 0.0223 times 30 power. So m of 30 is going to be approximately equal to $39.04. And I'm going to go ahead and box that answer in.